All righty, so we are going to read the article, but first, before we dive in, testing strategy, we know we're going to have to answer questions about it, so let's pull it to the questions. On the third page. For those of you just getting back in the room, we're going to read our questions first. Okay, because that helps us know what we need to focus on when we go to start reading. I'll switch it. All right, for the statements below, you will be selecting true if you agree, false if you disagree. Banner, I said if that particular color is not sharp, it's okay. Just use a different color. False if you disagree. If the statement is false, you're going to have to rewrite it to make it true. If the statement is true, you're going to have to explain why. Or how you know, right? Evidence from the text. Got it? Understand?
Yeah.
Understand?
Understood.
Okay. So first question we're going to be looking for is whether or not waves are only found in the ocean. I think they can go ahead and answer that right now. If you think you already know the answer to that, you're welcome to go ahead and answer as far as circling true false. Second question. Waves can cause objects to move. You don't have to answer this right now. Just these things we need to be on the lookout. We're just reviewing the questions before we read to help us know what to focus on while testing strategy. You heard that before? Yeah. Read the questions first. All right. All ocean waves, I'm looking at number 3, have the same amplitude. Number 4, waves are not very useful in daily life because nobody uses Morse code anymore. All right, well, let's read. Flipping back to page 1. You don't have to just annotate answers or text evidence. If there's something that you think is interesting or that you want to know more about, this is yours. Okay? You are welcome to annotate that too. And when you take it home, use it to research it. Okay? Where do I want to sit? I want to come. I'm going to sit down here. Are y'all going to be able to hear me if I sit down here?
Yeah.
I'm asking 2 specific people. Are y'all going to be able to hear me if I sit down here? Can you move if you can't? Okay. All about waves. Listen carefully. Can you hear anything right now? Even if you can hear a tiny sound, that means there are sound waves around you. All kinds of waves are all around us. You can't see most waves. However, they play an important role in life. What are waves? Waves are the way that matter transfers energy. When energy moves from one place to another, it moves in waves. Sometimes you can see them. Sometimes you can't. Some examples of waves are waves in water, sound waves, light waves, and even microwaves, like the ones used in microwave ovens. Types of waves. There are 2 main types of waves, mechanical and electromagnetic. They are different in one major way. Mechanical waves require a medium in which to move. Some examples of mediums are water and air. This type of wave needs molecules to move through. The molecules bump against each other, which helps the wave move. Electromagnetic waves don't need a medium. That means that they can move even in space, where there's no air. They travel through special electric magnetic fields. Charged particles generate these fields. Some of these waves are light, microwaves, and radio waves. Other important types of waves are transverse and longitudinal waves. Transverse waves are the waves you see in water. They move up and down, left and right, or right to left. Logan, that's distracting to me. Is that something that has to be done right now? Can you just grab any pencil from the dull or sharp bin in the back, please? Or dull, the whole basket in front of you. In the future, can we please be prepared when it's time to work? Thank you. Longitudinal waves are different. They act more like a coil spring. Imagine the spring is laying on the floor, and you pinch it together and let go of one end of the spring. The energy will move through the spring into a wave. We saw an example of that Bill Nye video, didn't we? With the slinky?
Yeah.
Another way to describe these waves is that they push, compress, and then spread again, moving in a direct line. Sound waves are longitudinal waves. Oh, caption, just kidding. How can you describe the waves shown above? Can they be described in more than one way? Let's see, they are mechanical, because it's water. I said water is an example of mechanical waves. And they are this kind. They're the transverse ones. They said ocean waves are this kind. They're not the spring, right? They're the same. I'm on the next page. I'm getting ready to start reading the section, Parts of a Wave. Really? Sit. Thanks, Lisa. When you imagine a picture of a transverse wave, it looks like a rope moving up and down. To talk about this kind of wave, scientists use special words. Two important words are amplitude and wavelength. Imagine a line that goes right through the middle of the wave. This is the resting point. The distance between the resting point and the high points above the crest, or the low points below the trough, is the amplitude. The energy of the wave is bigger when the amplitude is bigger. The distance between high points is the wavelength. The wavelength tells you the frequency, or how much energy the wave has. Next section, waves move objects. Sometimes waves can cause objects to move. Waves themselves are energy. However, that energy sometimes moves things like water. This happens when lake or ocean waves move boats and move water that hits beaches. Another example of waves moving items is sound waves. When you hear really loud music, you ever felt vibrations? Sometimes a loud bass can cause objects around them to move just a tiny bit. For example, a pencil might move a little bit if it's sitting on a table where a bass speaker is also sitting. Raise your hand if you've ever seen the mirrors in your car jiggle to the bass of a song. Yes. Nothing else. Waves and patterns. Very last section, we're almost done. Waves are very useful for making sound, light, and heating up food. We can also use waves and patterns to communicate. One example of this type of pattern is Morse code. Morse code is a special code that uses sounds or flashes of light that represent letters. The code is a mix of dots and dashes. The dots are short beeps or flashes. The dashes are longer beeps or flashes. For example, the letter A is one dot and one dash. However, the letter H is four dots. Then people listen or watch. Can we stop thinking about them talking? People listen and watch the code and turn it into letters. Morse code was used with telegraphs for many years. It was also used during World War II to help armies communicate with each other from far away. Other patterns also help us communicate. For example, computers use patterns of zeros and ones. It's called binary language. Also, music is stored in a pattern of ones and zeros. Ones and zeros. Computers, phones, and other digital devices can read the pattern very quickly. They know how to turn the pattern into an image, sound, or an action. Now, the caption. The device pictured above is used to create messages using the Morse code. Morse code can be transmitted via electric current, radio waves, visible light, or sound waves. The waves are present when the dash or dot is sent, and then the wave is absent during the pauses between dots and dashes. All right, so then it is up to you now to finish. Lily, come back to 16, girls. Waves are only found in the ocean. True or false? False. So you have to go write a sentence that makes it true. Waves are found, and then you have to finish it. Don't answer it to me. It's just something you've got to do. Waves can cause objects to move. True or false?
True.
True. But that's not all they are, right? Waves are what? Waves are what?
Energy.
Ella, energy moving. The energy moving can cause other things to move, but it's not the same. Let's see, number 3. All ocean waves have the same amplitude. False. Good job, Cooper and Charlotte. Thank you. That would make surfing very boring. If all waves were like the ones we think of. Some waves are big, some waves are small, right? Amplitude changes. And a tsunami, yes. Huge amplitude. All right. The last one. Waves are not very useful in daily life because nobody uses Morse code anymore.
False.
False. So you've got to rewrite it to make it true.
We still do.
Waves are, but you got to tell me why. Are useful. And you've only got about 12 minutes. We go get some charts, yes. Some of them, like the first one especially, I think is good off the news. But if it's stuck, or if you don't know how to spell something, I encourage you to go look at this. Someone gives you. And sometimes these words are big. Let's see what you got. Right, but where are they from? He says only in the game of the times. This tells me where they're found. I was more found. To be clear, that first question is not just talking about waterways. It says waves. Is there more than one type of wave, guys?
Yeah.
What kind of waves are there? There's water, yes, but what else, Raylan? Sound and food, light, and do we know another one? Microwaves and radio waves. You already said sound. So the point is, it says waves are only found in the ocean. That's not true because there's more types of waves than just water waves, right? So if you are saying something, Stefan, please stop drawing. Should be writing, not drawing, or listening. That would work too. You could say waves. No, they're not only found in the ocean. You can find waves in your sink, your bathtub, your lake. Sure. But the question is wanting you to realize there's more than just water waves, right? Waves are not just in the ocean. Waves are where? Charlotte? Everywhere. And you could even quote the text on that. It says in the very first little part, it says, all kinds of waves are all around us. Right? Waves are not only found in the ocean. There are all kinds of waves, and they're found all around us. All of this is with evidence. This is to help you organize your house. This is a tool. Okay. So, I'm going to questions. Okay, and all you do is found two. Waves are only found in the ocean, so there's nothing clear locate. You're saying that's false. They're not just located there. So you're telling me there's different types. Where can we find those other types? Like they are found all around us, slash everywhere, right? Not just in the That's why I said we're back to Reddit again. And I read this part. All kinds of waves. Not just ocean waves, right? Not just in the ocean.
Right?
So, this isn't from the text. You see if you can find somewhere in the text that talks about waves causing things to move. Types of waves. Types of waves. Oh, somewhere in here. Hey guys, pay attention to your headings and your subheadings, right? Number 2 is talking about waves causing objects to move. There's literally a section titled Waves Move Objects. So you know where to look for your answer, right?
What is this? Because over here. Oh. There's going to be that here. That's what this. What's this? Influence. What is this? You got it's in this. This parts of wood. What?
So how do y'all do work leave on your back? Oh, good. I said this is not.
Is this even snake?
So while
Can you sit up with